Good afternoon. I'm glad I'm able to have you guys in class today, and sorry I'm not able to be here. I have a meeting I have to get to. I need y'all to be on your best behavior, work for this sub, and be able to get this assignment done. Yes, I am grading it. Yes, I'm getting these papers back, all right? So today, what we've been doing so far is we've been solving for x when there's a x on both sides of the equal sign. We're going to continue that process, all right? This time, though, it's changed just a little bit to where we are going to be doing our own equations from a word problem. So step number one that I'm going to have you do when we're approaching this word problem is we're going to identify the things that go on each side of the equal sign. When you have x on both sides, that means you are comparing two different items to each other. And if we can tell what those two items are, we can start to isolate the numbers that go with them to write an expression, which is what step number two is, right? Step number two says write an expression. Step three is write the equation using those expressions. Now, I've got a question. How many of y'all remember what an expression and an equation are and what makes them different? An expression is something like 2x plus 3. That's an expression. That's all an expression is. In order to turn an expression into an equation, all I gotta do is set it equal to something. That's all I gotta do. From that point, if we have two expressions that have x on both sides, if we stick an equal sign in between them, then we're still having an equation here. This is still an equation. It just has two expressions on both sides. The first expression is going to be the 2x plus 3. The second expression is 3x plus 5. And by sticking that equal sign in between, we can solve them. Oh, by the way, we can easily solve this, all right? To solve it, I am going to subtract 2x and subtract 2x here. Cool. That gives me x plus 5 equals 3. And when I subtract 5 on both sides, I get that negative 2 equals x. Hang on, we just solved a variable on both sides equation. No problem, right? The hard part is, can we write this equation? So let's take a look at that first example that's on the bottom of the page there. Coach Hughes is purchasing trophies for end of season awards. Sweet, so we know he's got trophies that he's buying. So now where do these expressions come from? Next sentence. Williams Trophy Shop lets you create custom trophies for $5 per trophy and a fee of $75. Now, to be extremely honest here, Coach Hughes likes that option from William. I'm going to put a W for William. The expression for this lets us look at the numbers that are given to us to see how this changes. Notice, he's buying trophies at $5 per trophy. So if every trophy here, I'm just going to draw this real quick, equals $5. Oh, and in addition, we've got a $75 charge that's on there. If I'm looking at how much he's paying for this, what does that depend on? Well, it kind of depends on how many trophies he's got, right? So that depending on how many trophies he's got is a hint that if the number of trophies go up, the price goes up by how much? $5. That's where I understand that my 5x, x being how many trophies he gets, because we don't know how many he's going to buy, plus that $75 is going to be what the expression is for Williams Trophy Shop. He's got another choice, though. He's got Catherine's trophies. I'm going to put a K for Catherine's. Notice those trophies are on sale for $7 each, and they charge a fee of $25. Hang on, if each trophy is $7, then that's going to be 7x, because again, I don't know how many kids are getting trophies. That's something he's going to have to figure out. But what I do know for sure is that the $25 fee is going to be added to the cost of those items, okay? So when I look at this, I finish off that sentence, that reading paragraph there, and it says, how many trophies does Coach Hughes need to purchase to have the cost for both companies be the same? When we hear the same, we're hearing that they are equal. I'm seeing that this is 5x plus 75 equaling 7x plus 25. They are equal to each other. That's the equation I'm solving. Literally 5x plus 75 equals 7x plus 25. Teacher, if you would please, I need you to pause the video for about 3 minutes while my students begin working on solving this for x. You're going to have to start moving the smaller x. You're going to have to start moving those numbers that don't have x, dividing, all that stuff, okay? I'm going to need you to pause it for about 3 minutes, starting now. All right. Welcome back. So I'm going to go ahead and solve this for you so you can see if you've gotten it right. Minus 5x on both sides because that is the smaller x. That leaves me with no x's over here with a 75. 7 minus 5 leaves me 2x plus 25. Minus 25 gives me 50. 50 equals 2x. I divide both sides by 2. 25 equals x. What that means is if he gets 25 trophies, it doesn't matter which shop he goes to, the cost is going to end up being the same. Okay? So let's go ahead and look at the next equation, which is going to be on the back. Again, that equation hasn't been written for us. We have to write it for ourselves from this equation. Okay, so the Krusty Krab offers a party package that costs $150 to set up and an additional $2.75 per Krabby Patty that is ordered. You guys know when you go to Chuck E. Cheese's for a birthday party that you had to pay to be able to have your party there, and then you had to pay for the number of people that were coming, but it was at a discounted rate, right? That's the kind of thing that's going on here. Mr. Krabs has said, okay, I'm charging you $150 to just have a party at the Krusty Krab. But your Krabby Patties are only going to cost $2.75 each. So if I start adding more people, how much more are we charging for each person that we're bringing? Well, I'm not charged $150 per person. The $150 is charged just to set up the party. I'm getting from the Krusty Krab a $2.75 charge per person plus the $150 that were charged for setting up that party. I'm going to use text so I can make it fit a little bit better. Okay. Again, it is $2.75 per person plus the $150 that we are charged for that party. If I keep reading though, the Chum Buckets. Plankton's got its own version of the Krabby Patty that only charges $100 for that party fee, but charges $4 for each Krabby Patty. How many Krabby Patties need to be sold for the profits of both companies to be equal? So if I look at the Chum Buckets, he's charging more per Krabby Patty, isn't he? He's charging $4 per Krabby Patty. And since that depends on how many people show up, that's where the X comes from. But he's only charging $100 for that. I don't know why it's not stretching out. I apologize. Let me backspace a couple of things real quick. He's only charging $100 for that party to be set up there. Okay? So, in this case, I do want to ask, because it is an important question, which one of those has a steeper slope? Now that slope idea is interesting. Which one of those has a steeper slope? If you're thinking that's the Chum Bucket with Plankton has a steeper slope, I agree with you. And the reason for that is because your slope is a description of the rate of change. It means how much more are you earning for one more of that same item. It's what rate is going to make your profits increase faster. That means that this is going to be a steeper line. Why is that important? Well, because he's charging less for that party setup. He's targeting people that aren't going to have a lot of people at that party. He's going for the small groups that are coming. Let's take a look and see what this is going to look like as an equation. I'm going to say that my 2.75x plus the 150 equals 4x plus 100. And I'm just going to write that here so that we can see it. I don't know why it doesn't let me adjust the size of that because it absolutely should, but it's whatever. Okay, $2.75 per person plus that $150 is equal to the $4 per person that the charge from Plankton is. I didn't do 4.00, but if you like seeing 4.00, so you see it's $4 per person plus the $100 charge that you're charged for setting up that party is going to be fine. Once again, I'm going to have us solve for each side of the equal sign, okay? I'm going to have us pause it for another 3 minutes. I'd like for you to solve for x on both sides. Again, move the x, subtract the other number that's not an x, divide, you'll be fine. 3 minutes starting now. Okay, welcome back. So, to solve this isn't too bad at all. If I subtract on both sides $2.75 x and a minus $2.75 here, I end up with $1.25x plus 100 equals the $150. I subtract 100 on both sides. That leaves me with $50 equals 1.25x. If I divide both sides by 1.25, that would be 50 divided by 1.25, giving me 40. 40 equals x. If you buy 40 Krabby Patties, it doesn't matter if you go to the Chum Bucket or to the Krusty Krab, the price of this is going to be the same. I've got one more example for you to complete. And for this, I'm gonna let you do it almost all the way yourself. Notice, I took apart that top part where we're setting up those two expressions. I'm only asking you to write the equation with the x on both sides and to be able to solve it. This statement, Mr. Ring has 2 credit cards that he is paying off. Card A has a $100 balance on it that he pays off at $8 per month. Card B has a balance of $250 that he pays off at $23 per month. How many months will pass before the cards have the same balance on them? Notice that word, the same, they're still going to be equal to each other. Your goal is just to write the equation and be able to solve for x. For this, I'm gonna have 2 pauses in place, okay? The first pause is gonna be for about 90 seconds, a minute and a half. If you need a little more time, you can leave it paused longer, teacher, I apologize, but you can if you think the kids need a little more time. I would like for you to start by writing the equation, okay? So, in about 10 seconds, the video is going to be paused for that 90 seconds or so. Write the equation. You can then check it to the work I'm showing. I'd like for you to pause it about now. All right, so what does that equation look like? Not as bad as you'd think. We have 2 cards. Card A has a $100 balance, and I'm paying it off at $8 per month. 100 minus 8x. And that x represents how many months have passed. If it's only 1 month, it's only $8 off. So 100 minus 8 would give me $92. But if it's 2 months, 8 times 2, 16. 100 minus 16 is going to be 84. Okay, we're seeing how it's starting to get paid off. But, what about the other side? It starts at $250 and we're subtracting $23 per month. Once again, that x goes there because however many months pass means another $23 for each of those months is going to be paid off. We can now solve this for x on both sides. Here's where that second pause comes in, teacher. I apologize again that I'm making you do all these pausings in here, but I'd like these kids to have the chance to practice it on their own, okay? I'd like for you to solve for x on both sides. If you don't mind pausing it in the next 3, 2, 1. All right, how do we solve this? Well, we actually add 23x on both sides. If you added 8x on both sides, you'll still be fine. You'll just end up with some negative numbers. You'll see a lot of your numbers end up matching, okay? I get 100 plus 15x equals 250. When I subtract 100 from both sides, I end up with 150 equaling 15x. When I divide by 15 on both sides, I get where x equals 10. This is going to be 10 months worth of paying stuff off until both cards have the same balance left on them. Now, I can tell you they're not paid off to zero. I can promise you they're not. If we said 10 months, 8 times 10 is 80. 100 take away 80 means I've still got $20 left. 250 times, or minus 23 times 10 is 230. That's still got $20 left too. So I've still got money left on these cards to pay off. But after 10 months, they both have $20 left on them. And that's what the question's asking for. That's why the answer here is x equals 10. You've got a worksheet that you're going to be working on just now, and I would greatly appreciate if you would begin work. Thank you.